Good day. This is the first part of a series of video clips that I am preparing for economics students, or rather for SBL students who are studying economics in their first year of studies. The course looks at micro and macro economic concepts that have been selected from the prescribed textbook. Just want to say beforehand that the structure of these videos or video clips follow to a degree the lecture slides that have been posted for you on the EDS system at the SBL. And the particular set of slides that I'm referring to would be those that are of a shorter version. It's about a series of about 50 slides in total that you should look at. But I want to also say that I'm not following each slide one by one, but just broadly I'm using them to guide the clips that I'm presenting to you. But I'm focusing particularly on the concepts that I think often pose difficulties in students trying to follow. So in classes broadly, what we've often discussed is how important history is, not just to the economics discipline, but history is very important to various academic disciplines, because it tells us how models are building from one into another in a very slowly incremental or marginal way over time. In economics, the 17th century is very important, as we discussed in class. Why? Because very important developments took place at that time, but also because we think of that century as a century when economics as a discipline was born, as discussed by scholars like Adam Smith, who also wrote the book on the Wealth of Nations, where he discussed how trade, the virtues of trade, were so important in leading to economic growth in the world. So Wealth of Nations is about how nations have grown over time, especially in the last 200 to 300 years. So our economics is really divided, and like I said earlier on, into microeconomics and macroeconomics, and we start off first by discussing microeconomics, because historically that's how economics itself got developed, through microeconomic ideas. For instance, international trade ideas. So this course in a way follows that kind of chronological order, which is historical. Trade is important, and so Adam Smith and various people who were discussing virtues of trade at the time pointed out that being able to bargain as consumers who want to consume different types of goods is important for us to find what we want. And the same logic really applies to producers. Producers, being limited by their own inputs, as constraints, as well as their own budgets, they still have to make decisions based on what is demanded in the market, as well as what they can produce given their own internal limitations. But then traders, both sellers and buyers, have to get together and trade for the right resources with the right amounts to be determined. And that is really how a competitive market works. Adam Smith referred to that as the invisible hand, which would be allocating the right amount, efficiently the right amount of resources to the people who were demanding those kinds of resources. But it's all within various limits as determined by the availability of natural resources. So I'm not going to go through all the history that I've put onto those slides that we discussed in class, but I think it is important for you to go through that history on your own. What I'm going to get at very quickly is for you to understand the basic mathematics that is required for you to understand economics. So in class I talked to you that, and I said to you, economics is very much a positivistic approach or discipline to how we inquire about knowledge, or how knowledge is accumulated, or how we learn, basically, in simple terms. So it is in a very positivistic way, and it's a modernist approach in a sense, where we observe what is going on in the world, we make hypotheses about what is going on, and then we formalize those hypotheses. We then go collect data, which we then analyze and test whether our hypothesis can be accepted or rejected, and then we conclude. And that is really a typical scientific way of going about accumulating or learning about how the world works. And so economics relies very much on formalism. So it relies very much on mathematical language, and that includes graphical language as well as algebra. So it is important then for us to understand very basic mathematical language, so that it would be easier for us to understand the economic concepts as presented in that mathematical language. In class I began by telling you that what I found very interesting in economics is how the Cartesian plane, as we know it in mathematics, was not always used, or in most cases it was only the first quadrant of the Cartesian plane that was often used. So in your mathematics, basic mathematics algebra, you would have learned that, at least in 2 dimensions anyway, that the Cartesian plane is divided into 4 quadrants. And this would be the first quadrant, right? This would be the first quadrant, and that's the quadrant that I'm referring to, that often it's the quadrant that is used in economics. And this would be the second quadrant, the third quadrant, and the fourth quadrant. In economics, it's often this quadrant that is used if this is y, the y-axis, and this is the x-axis. And this is really on two dimensions, as can be represented either on the board or on a piece of paper. And I said to you, one of the reasons why economics often uses the first quadrant as opposed to all the other quadrants is because of the social phenomena, the way that people understand social phenomena. And it's never really in negative, it's always in positive senses. Sometimes we use the fourth quadrant, and you will see examples of that. In fact, some of those examples are discussed in your slides, and I give you the relationships that use the first quadrant, and some that use both the first and the fourth quadrant. But we hardly use these other quadrants, especially the third quadrant, which is negative x and negative y. So both the variables are negative. So we hardly ever use this quadrant. Sometimes this one is used, but this is the most predominant quadrant that is used in economics. This is not only in economics, in fact, it is also in other social sciences like sociology, like psychology, as opposed to in chemistry where these other quadrants, or in mathematics, where these other quadrants make mathematic sense, but in a way do not make economic or social sense. So, for instance, if you were consuming a good, or you demand a good, we would have a negative relationship between the price of that good and the quantity demanded of that good. And that relationship would be negative. But we don't really talk about the point where the price of the good is zero. What is the demand for the good? Or the price of the good is, what does it mean what does that mean? You've got a negative price for the good. Could it be a bad, for instance, that one would have to be paid to consume that good? So we don't really talk about, when you don't go into a shopping mall and then go to a shop manager and say, please pay me, pay me for me to be able to take this particular good that you've got on display. So those types of concepts do not make socio-economic sense. So that's the reason why these other quadrants are not really used in economics, but this one is the most predominant one. For instance, on slide 19, you see a relationship there which is positive and which is about the South African population and time. So on the y-axis you have the population, and then on the x-axis you've got time. And we don't talk about negative time, for instance. So time would be here, and the population would be there. If this is the origin where the x is 0 and the y is 0, but we don't really talk about this time. In fact, we start off at time 1976, or whatever is there on your, or 1996, sorry, on your slide. And then we look at what has happened to population, South African population, and how it's grown since that time up until, say, 20 January of 2012. And we see a positive relationship between population and time. But we don't have this relationship coming onto this quadrant where the population is negative and the time doesn't make socio-economic sense for us to talk about a period in time where the population was a negative. What does that mean? It has no meaning in socio-economic sense, or just in social sense. It may be important for geologists, or for a paleontologist, I don't know, for a biologist, for people talking about the Big Bang, you know, maybe the Big Bang would be somewhere there, the beginning of time. So for physics, maybe it's important, but for economics, no. So in any case, the point is, this is the most predominantly used quadrant in economics as well as in other social sciences. On your slides, I'm giving you various examples of relationships which are predominantly on this quadrant. And those relationships are the ones that we discuss also in this module. And I want to say also that most of our relationships, or the relationships that we discuss in economics, in first year basic economics, are linear relationships, or we approximate them to being linear relationships. For instance, the relationship between price and the quantity demanded would be a linear relationship. You know, a straight line in basic economics. Look, in some textbook it's not represented as a straight line, it's a curve, but for all basic purposes we represent these relationships as linear. And that really makes it easier for us to deal with the various economic relationships. Sometimes we have quadratic relationships. For instance, on one of the slides, I talk about the relationship between age and earnings. So on the x-axis, I've got age. On the y-axis, there are earnings. And I say that, well, you know, as you grow up somewhere, say around about the age of 16, you start earning some money, and this income grows, and then maybe you get a degree, and then, you know, maybe it grows even further. But at some point, it starts to flatten out, and then you retire. The age of retirement comes in. Look, you might still continue working, but you're not working as much as you were working previously, and then you might find that your earnings start to drop. Your income that you get from actually being employed or working starts to drop, and then it gets to a point where probably it will just, you know, drop to zero. where you are not earning any income anymore, but your income probably comes from your savings, from retirement savings, etc. Or it could be coming from renting out property and other various sources of income. So in a sense, they will be having some kind of a quadratic relationship between age and earnings, and maybe somewhere there would be the age of 65, which is normally the retirement age for most countries. So the relationships that we often have in economics are linear, and in basic economics, really, some of them are quadratic relationships, but really we often focus to linear equations where y equals to some intercept, say a, plus the slope of the relationship that you are talking about, and x. Okay. So this slope, sometimes especially in regressions, we refer to as the coefficient, which really is a representation of this variable y and that variable x. So, for instance, in a relationship that was positive, where y was positively related to x, you could have that b there as being a positive value. And then you could also have a relationship, for instance, the one that we looked at just now, which is negative, where y is negatively related to x, which means that as y increases, what is happening to x? X is decreasing. That represents a negative relationship. That would then mean that b there takes on a negative sign, because it really is the slope of that relationship, of that linear relationship there. Whilst a is your intercept, your y-intercept. Maybe in this case, it would probably come there, say about 1, or whatever it is. It could also be a negative. But like I said, in most economic concepts, we hardly ever have a negative slope. But there, you've got it. There it is. Your a there could be, say, 10. It's a positive 10. And it just tells you what the value of y is, when x is 0. And those are the most important concepts or variables that we are interested in when we're looking at relationships between two variables in economics. Where does that relationship intersect the y-axis? In the case of earnings and retirement age, you would be asking yourself, when are the earnings 0? Okay, when are the earnings 0? That could be important. In the case of your demand, the demand function, you could be asking yourself, when is 0 of this quantity being demanded? At what price is nothing being demanded? At what, if this was P and this was quantity demanded? That could be important. Okay? And as I said, as well as that the value of B, which is the slope. Because the value of B really tells you as y increase, by how much x is increasing. So what is the relationship? Does y increase by 10%, and that leads to an increase of 10% as well. So you've got a 10% to 10% increase, which would then mean that your B equals to 1. It's a 1-to-1 relationship. 10% increase leads to 10% increase. Or it could be a -1 relationship, where a 10% decrease leads to a 10% increase. In the case of a negative slope. So those slopes are very important. That slope is very important for us in economics, and we often look for that slope, which really tells us what the relationship is between the variables that we're looking at, as well as that intercept. That in many cases becomes an important concept to look at. So what now I want to discuss next are the concepts starting on from your chapter 1. So concepts such as choice, scarcity and opportunity cost, and that I'll discuss in the next video clip.